So last time I mentioned that these formulas exist, and I showed you how to prove this one. And I'm going to use the same kind of idea to prove this next one, B. And while I'm not going to be showing you how to do this one, it's basically the same idea. So for example, if you wanted to know what's the summation of I to the fourth power, then you can just follow the exact same procedure I'm doing here to get any power afterwards. Okay? It just takes time. Right? Okay, so I'm going to prove B. But to do that, I need to ask a question first. So the first question is, if summation of the first n sequence of numbers gives you n cubed, and the reason I'm talking about n cubed is because you see the right side, n times n times n, that's n cubed, right? So this, if you expand this, it's a polynomial of third order. And whatever that is, you're going to ask the following question. So for example, if you want to settle this one, if you want to prove this one, you'd be asking what adds up to n to the fourth power, and so on and so on. Okay? All right, so suppose you have sequence of numbers whose nth summation is always n cubed for all n greater than 1. Okay? 1 or greater. Okay? And the question is, what is AI then? That's the question. Now, how do you answer this? Well, AN would be I from 1 through n of AI. So what is this? This is A1 plus A2 plus A3 all the way up to AN, right? Now these two are clearly not the same, right? But it will be the same if I subtract something. Now can anyone tell me what I should be putting here?
N minus 1.
N minus 1. Because if you subtract AN, then nothing survives, right? If you do this, then these two summations have exactly the same stuff except for AN. This is A1 added until AN, right? A1 plus A2 plus A3 all the way up to AN. This one is A1 plus A2 plus A all the way up to AN minus 1. So if you cancel out the same things that appear in both cases, the only survivor is AN. Get it? Now, then we're going to use this given. So what is this equal to? What is this equal to? Huh? N to the third power. It's right there. I'm not asking for something hard. Every question that I'll be asking in this part will be something that you can figure out just by thinking. There's no previous knowledge required, because that's summation. It's like you think of it as something that you've seen for the first time, and everyone in this room has seen sigma for the first time. So that's what I'm assuming. So if you just pay attention, you can answer everything I ask. Okay? All right. So what should this be then? Say it.
N cubed minus 1.
Close, but not really. Yeah.
N minus 1 cubed.
Yes, n minus 1 cubed. Right? Because the only difference is you're basically taking this one and replacing n by n minus 1. So if you replace this n by n minus 1, all you have to do is replace this one by n minus 1. That's why this is true. Yes?
I forgot if you said that this is also going to be on the test. Is this also going to be on the test?
Yeah, I'll probably put it on the test. Yeah. You're only going to pay attention if I say something. That's right. Okay. So let's try to simplify this one. What is this?
N cubed.
Well, you have to FOIL it out, right?
Yeah. So that's the first one.
And the very first one will be n cubed.
Minus 2n plus n. Wait, would that be squared? N squared?
All right, let's just do it one by one. This is the first two. So it's n squared minus n minus n minus plus 1, right? You FOIL it out, right? N minus 1, which is like n squared minus 2n plus 1 times n minus 1. So that's going to be n cubed minus 2n squared plus n. So I just did this first, and then I did that here. So the result is n cubed minus 3n squared plus 3n minus 1. So that's equal to n cubed minus n cubed minus 3n squared plus 3n minus 1, which is 3n squared minus 3n plus 1. Okay, so now we have an answer, which is that since an is this, we see that ai must be 3i squared minus 3i plus 1. Okay, so let's write down the result of what we found here. We found out the summation of I from 1 through n of 3i squared minus 3i plus 1 will give you n cubed for any n. Now what does that mean for, let's say, n equals to, let's write this in longhand and see what it means. Okay, so if you plug in 1, 3 times 1 squared minus 3 times 1 is 3 minus 3, so you just get 1. If you plug in 2, 2 squared is 4, 4 times 3 is 12, minus 6 plus 1 is 7. If you plug in 3, 3 squared times 3 is 27, minus 9 is 18, 18 plus 1 is 19. Let's just do one more. If you plug in 1, 2, 3, 4, 4 squared is 16, 16 times 3 is 48, minus 12 is 36, 36 plus 1 is 37. Keep adding all the way up till the last point, which is n, 3n squared minus 3n plus 1. That's the last number, right? And this will result in n cubed. Now, if you're wondering about the pattern, these numbers actually have patterns. So this is like 6 apart, and this is 12 apart, and this is 18 apart, right? So the next number should be how much apart? 24. So 37 plus 24 will be 61. So if you add this much, you're going to get n cubed. So that's what you're seeing. Now, the next question is, how does this have anything to do with figuring this out? Well, now we just apply all the properties of sigma, which is you can break up this summation into each individual summation, and we can bring out the constants in front, right? So you're going to get, this really says 3 sigma 1 through n of I squared minus 3 I equals to 1 through n I plus sigma I from 1 through n of 1 is equal to n cubed. So I broke it up and brought any constant multiple outside. Now why do I want to do that? I want to do that because I'm interested in this one. So we'll find out what this is if we just solve this entire equation for this thing, and we're done, right? And here we're assuming that I know what this is. What is this equal to? What is this equal to? No.
And the right.
Huh?
The observed.
Yeah, it's right there, right in front of you. I'm not asking hard questions here. It's right in front of you, right? You just have to pay attention and you can figure out what it is. How about this one? What is this same as? What does this mean? You're adding 1 plus 1 plus, yeah. So what would you get?
1 times n.
1 times n. You're adding 1 n times, right? So it's just n. Okay? So this is going to be right? So we can subtract n here. And then, oh, let's just say I'm moving these to the other side. So you have 3 it'll be like this, right? Then we divide by 3. And then we see that this is over 3, that's over 2, so if we want to make them into a single fraction, we better multiply 2 top and bottom here, and 3 top and bottom here, so that everything is over 6, right? And then, since I multiply by 2 for this one, it's 2n cubed minus 2n, whereas this is n squared plus n, and I'm multiplying by 3 top and bottom, so it's plus 3n squared plus 3n, and this results in 2n cubed plus 3n squared plus n over 6. So that's the answer, right? I wrote it like this, but if you FOIL this out, you'll see that this is exactly the same as this one. So these are the same formulas. Okay. So we proved B. There's something that's interesting about this approach. If somebody presented you this result, that you start from 1 and you just get the next numbers by multiples of 6, adding multiples of 6 like this, and they say if you do this, you always get n cubed, some cubic number as your answer. And when you see it for the first time, you might say, wow, that's crazy, how do you get that, right? But then you would stop there, and you wouldn't be able to start from here to deduce this formula. It would be hard. Why were we able to deduce this formula? Well, that's because we passed from this longhand to our shorthand, right? And if you write it in shorthand, you can apply the properties of sigma that, I mean, you can still start from here and get the same result without using the sigma notation. It's just that it's harder to see these transformations. Only when you do the shorthand you can easily see that these are possible. These calculations here you've done are possible. So the lesson here is that although shorthand is equivalent to the longhand, sometimes having a better notation with additional knowledge about its properties enables you to see the problem in a new insight so that you can actually get the formulas that otherwise it would be hard to get. Okay? So that's some nice thing to know.